Welcome to This Explainer. Look, if you've ever tried building software with AI coding assistants, you already know they're incredibly powerful. But let's be totally honest here. Without a structured method, they can spit out some seriously chaotic, inconsistent, and sometimes just totally incorrect results. It's frustrating, right? Well, today we are going to fix that. We're going to talk about transforming that chaotic AI coding process into a highly predictable, high-speed assembly line using what's called the BMad method. Okay, let's dive right into this. Our agenda today covers the AI tool trap, spec-driven development, the upstream thinking phase, the downstream building phase, and finally, the continuous delivery cycle. Section 1, the AI tool trap, escaping the magic autocomplete. So we really have to acknowledge the elephant in the room here. Is AI actually writing your code, or is it just writing your technical debt? For a lot of developers right now, current AI coding assistants are honestly just generating bugs faster. And we've all seen the symptoms of this unstructured approach. When we treat AI as this sort of magic autocomplete, where you just paste a vague prompt and cross your fingers, we end up with hallucinated APIs. We get these endless, frustrating rework loops and rapid scope creep. And because context is totally lost in every single new chat, your technical debt actually compounds even faster than human-written debt. It's like every conversation is literally starting from zero. Moving on to Section 2, spec-driven development, the paradigm shift. Now, what's really interesting about this slide is how it perfectly highlights the shift we need to make. We absolutely must shift our mindset away from immediate code generation. Look at the traditional workflow. It goes straight from a raw idea to code, which, surprise, surprise, inevitably leads to bugs. But the BMad workflow, it goes from an idea to a validated specification first. You see, AI is absolutely exceptional at translation, not invention. If you give it a precise spec, it will translate that into precise code. So what exactly is spec-driven development? It's basically defined by writing your verified specifications first. That makes the actual code generation the final, almost trivial translation step. The core, absolute game-changing insight of BMad is that the bottleneck isn't generating the code anymore. It's the quality of the spec. A perfect spec produces perfect code on the first try, period. And this brings us to the critical boundary line in the BMad philosophy. It essentially divides the entire lifecycle into two distinct phases, upstream and downstream. Upstream is your thinking phase. This is where you have high iteration, divergent exploration, and you produce your specs. Downstream is your building phase. This is all about strict convergent execution. The absolute golden rule here is that downstream execution agents should never, ever make upstream product decisions. Which leads us perfectly into Section 3, upstream, the thinking phase, from raw idea to system architecture. I like to think of this upstream process like an ensemble heist movie. You bring in these highly specialized personas to tackle very specific phases of thought. First up on the crew is the analyst agent. Their job is to look at a vague, raw idea with deep skepticism and curiosity. They basically challenge assumptions and ask why, transforming those unstructured thoughts into clear, actionable problem definitions. The analyst process is super rigorous. They start by just listening and absorbing the raw idea. Then they facilitate a brainstorm to really expand the thinking. You know, at this stage, no idea is too wild. After that, they dive into market research to see what's already out there. And finally, they synthesize all of this creative chaos into a solid, concrete project brief that clearly defines the what and the why. Okay, so once we have that validated brief, we hand it off to the project manager, or the PM agent. The PM is decisive, detail-oriented, and intensely user-focused. They are the ones who transition us from the analyst's product exploration into very strict, non-negotiable product requirements. The PM agent takes that project brief and creates your single source of truth, the Product Requirements Document, or PRD. They define the user personas, map out the workflows, and most importantly, they write incredibly strict acceptance criteria. This is crucial. If a feature or a detail is not explicitly written in the PRD, it simply does not get built. No exceptions. Next up in our heist crew is the architect agent. So while the PM determined the what, the architect's job is to figure out the technical how. They are highly pragmatic, systems thinking, and hyper-aware of trade-offs. The architect reviews the PRD and makes all those hard technical decisions. They're choosing the tech stack, defining the data structures, and establishing API and security patterns. Their final output is the architecture document, And guys, this becomes the absolute law for how those downstream agents are eventually going to write the code. And this brilliantly illustrates a vital concept in BMad: context engineering. Look, you can't just dump a massive 50-page PRD into a single AI prompt. The AI context window is exactly like RAM on a computer. It is finite, incredibly precious memory. Load what's needed, unload what's not. That's why we use sharding, breaking those giant specs down into focused, independently loadable pieces so the agents only see exactly what they need for a specific task.
All right, section 4, downstream, the building phase, strict execution and validation.
We are officially crossing the boundary line now. We're shifting the energy completely away from expansive thinking and moving right into strict, constrained execution. Our first downstream agent is the Scrum Master. They act as the essential bridge between those giant specs we just created upstream and the actual developer who will write the code. They are your pragmatic decomposer.
The Scrum Master takes the PRD and breaks it down into small, actionable, invest user stories. Then, the developer agent implements them. But listen closely, because in this phase, constraints are absolutely everything. The developer builds exactly what is specified, no over-engineering, 0. Rule 1, never invent architectural patterns. Rule 2, if they find any ambiguity in the spec, they don't guess, they push it right back upstream. In this phase, an AI guessing is treated as a total failure. Once that code is actually written, it enters the QA dev loop. The QA agent rigorously tests the implementation directly against the original story's acceptance criteria. If there's an issue, QA sends a completely objective, fact-based report to the dev. The dev fixes the root cause, not just the symptom, and QA does a quick verification. This rapid, tightly constrained back and forth is where the only true iteration should ever happen in the coding phase. Finally, Section 5, the continuous delivery cycle, accelerating the assembly line. This is where all of that strict discipline really pays off. Now, you might be looking at this timeline and thinking the upstream phase adds a lot of overhead. But actually, the overhead of rigorous upstream thinking dramatically accelerates your assembly line. Because your specs are flawless and the context is perfectly engineered, the downstream implementation and QA testing happen incredibly fast. There's virtually no rework or hidden tech debt. It's a flywheel, and each cycle gets faster than the last. I want to leave you with this final provocative thought. As these AI models continue to rapidly improve, the actual generation of code is going to become entirely trivial. When that happens, where will your competitive advantage lie? The future belongs permanently upstream, to those who have mastered methodologies like BMad to specify precisely what needs to be built. Thanks for joining me on this explainer, and happy building!